Alright, here we have, sorry. Alright, here we have one of the problems that gives a lot of students some trouble. Okay, it's a tension problem. We have a truck hauling a boat. Alright, the truck has a mass of 1,500 kilograms, and the boat has a mass of 800 kilograms. Now, the only other thing we know is we know that the truck has an engine that pulls. Let's call that engine of 6,000 newtons. The question is, what is the tension force on this string as it goes up a grade of 10 degrees? Okay? I guess not string, but cable. Okay, this is particularly important because, of course, we need to know these sort of things if we wanted to make sure that our cable was strong enough. So, tell you that, in a case like this of connected objects, one of the key things is you can break it up, you can treat the whole thing as one thing, or you can break it up into parts. So we're actually going to solve three problems. We've got overall, okay, we've got the truck, and we have the boat. Alright? Now for overall it's pretty simple. Okay, what are the forces on the overall thing? We've got the engine, which is 6,000, and we have force of gravity, which is pulling it back down the slope in the opposite direction, and that's going to be, we're going to find that again using our angle, which is going to be the mass times acceleration due to g, due to gravity, times sine of 10 degrees. Okay? And that comes out to be 3,914 newtons. Okay? In this case, there are no other forces acting along the path of the truck. We've got the normal force and gravity pushing up and into the in perpendicular to the slope, but we don't need to actually calculate those. Okay? So, those are our only two. Which means that we can figure out the net forces, and we get 2086. Oops. Now, from 2086, we can then find the acceleration, and it's going to equal 0.91 meters per second squared. Okay? Does that make sense? All right, now let's look at the truck. Let's divide right there. On our truck, we have three forces acting. Okay? We actually have the engine, right, because the engine's in the truck. Okay? We have gravity, just the gravity of the truck. And we also have the tension force, or the force of the cable. Okay? We know the engine is going to be 6,000. We know gravity, we can find it, is going to be very similar to how we found it here. Except in this case, we're not worried about the mass of them combined, we're just worried about the mass of the truck. So it's going to be a little less, and should come out to be 2,553. Okay? Now, we don't know what the tension force is. So if we were to set up the equation, we would get equals, we know the engine's pulling it upwards. That's minus Fg and minus Ft. Alright? Can't solve that. Don't have enough information. We've got two unknowns, Ft and Fnet. We're actually going to come back to this in a second, but I want to set up the boat one. You wouldn't necessarily have to do this, but I want to set up the boat one as well. Okay? For the boat, we only have two forces. Okay? The engine's not attached to the boat directly, so all we have is Ft. Okay? And Fg, which again is mg sine theta, or sine of 10 degrees. But again, we're using a different mass, just the mass of the boat, and we end up with 1361.4. Okay, perfect. And again, we have our Fnet is equal to force of tension minus Fg. Now why is the force of tension positive in this case and one of the last one was negative? Well, since it's going up the slope, I tend to assume that up the slope is positive and down the slope is negative, if that's the direction it's going. If it's going down the slope, maybe you do it differently. As long as you're consistent, it's okay. In this case, I'm making that way positive. Okay? Now, two things we have to consider now. First, the key to solving this problem comes in two places. First, we have to know that the tension forces are the same. Newton's third law, equal and opposite, tells us it's got to be that way. Now, that's only true as long as the cable doesn't weigh very much. In this case, the cable probably weighs, I don't know, 2 or 3 pounds, 4 pounds, 5 pounds, I don't know how much these chains weigh. But remember that that's almost nothing compared to the rest of the mass. So we can say the cable weighs nothing, which means that the tension forces are the same. Okay? And that would mean that they would cancel out overall on the overall problem here. Okay? Now the other thing we should consider is that we know the acceleration of the truck and the boat. Our overall acceleration is 0.91. That means that our acceleration of the truck and the boat have to be 0.91, otherwise they would separate. Which means we know F net equals 0.91 times 1500 equals 1360. Then plug that back into our equation. We have 1360 equals 6,000 minus 2,553 minus Ft, and we get the tension force to be 2,087. Now, if we're right about this, if Newton's third law is right, this Ft should be the same as the Ft we get here, and we can check that. Okay? Net equals 0.91 times 800. All right, and that equals, it comes out to be, what does it come out to be? 725.6. And we can plug into our equation. 725.6 equals Ft minus 1361.4. And that gives us Ft is equal to 2087. Exactly the same. So not only have we figured out what the tension force is, and therefore what the strength of the cable would have to be, we've also confirmed Newton's third law. So again, key here is you can set up into these three problems. You can break it down into as many pieces as you have in the problem. Okay, you can solve it overall, you can solve a truck, you can solve it both. And in all those cases, as long as you have all the forces involved, it should work out the same.